Cancer is one of the leading causes of death worldwide. Nearly 20% increase in breast cancer each year. The initial symptoms of this cancer are not always visible, and if it reaches stage 4, it will be difficult to heal. Cancer refers to a condition in which the body cells proliferation uncontrolled, which can damage normal cells around it. As for common symptoms, namely decreased appetite, limp, Western body drop drastically, as well as prolonged cough. More than 30% of total cancer deaths are caused by unhealthy lifestyle. Factors causing cancer include exposure to air pollution, cigarette and alcohol use, lack of physical activity, and less eating fruit and vegetables. Indonesia has biodiversity that has the potential as a traditional medicine, one of which is located on the island of Kalimantan, namely Bajaka Tampala, which is believed by some to be a cure for cancer cell growth because it contains antioxidants that can potentially be anti-cancer. Propolis is a resin substance collected by honeybees from plant sources such as sap stream of tree shoots. According to Ferreira, propolis is beneficial for health because it contains antioxidants. Various attempts were made to treat this cancer. From previous research, this Bajaka would only test the effectiveness of using the in vitro methods in healing wounds. Present potential test of Spatholobus literalis has and propolis as breast cancer anti-cancer using molecular docking methods to support national health and medicine. Here's our team: Alicia Hidatania as team leader, Lilin Putri Jasmine as a member, and Fadila Nurziata Turama as a member, under the guidance of an outstanding lecturer, Dr. Ari Sri Hardiastuti SSI MKes. The mechanism of our research is through literature and computational studies. Literature study is carried out by looking at the result of research in an online database such as Google Scholar, Science Direct, and Elsevier, published in 2010 until 2020. Our research is supported by computational study through molecular docking simulation. Docking simulation were performed to predict which ligands and receptors were targeted in the in silico test. Molecular docking can be done online by downloading the free application used. The application used include PDEX, Paymol, and Discovery. The keywords we use include breast cancer, Bajaka Tampala, propolis, molecular docking simulation, and breast cancer receptor. Bajaka Tampala contains camphorida, which is one of the active compounds that contain antioxidants and other components, namely chalcone and caffeic acid, which have the ability to act as strong antioxidants and anti-tumor and inhibit the proliferation of breast cancer cells in vitro. Propolis contains caffeic acid, pentyl ester, quercetin, and tangeratin, which are active compounds containing antioxidants which have ability to induce aging of cancer cells. The receptors we use are estrogen alpha and estrogen beta receptors, which play a role in forming heterodimers to stimulate transcription of genes that regulate cells proliferation, and VEGF, which play a role in stimulating endothelial cells in blood vessels to form new vascularity to cancer cells. The optimization result of the ligand geometry structure using software on Bajaka Tampala. Based on the table, the result of the optimization ligand geometry structure using software on Bajaka Tampala, it can be seen that the ligand has the most optimal binding affinity is the camphor ligand of -8 kilocalorie per mole at the alpha estrogen receptor. Binding affinity represents the binding energy required for the ligand to interact with the active site of the receptor, which is a measure of a drug's ability to bind the receptor. The smaller the binding affinity, higher the affinity between the receptors and the ligand. The result of the optimization of the ligand and receptor geometry structure using the propolis. Based on the table of the results of the optimization of the ligand's geometry structure using software on propolis, it can be seen that the ligand that has the most optimal binding affinity is quercetin ligand at minus 8,8 kilocalorie per mole at the beta-estrogen receptor. The optimization result of the geometric structure of the combination between Brawijaya ligands and propolis using software. Based on this table, the combination of Brawijaya and propolis will affect the binding affinity value. The optimal binding affinity is found in the interaction of camphoride and quercetin ligands with VEGF receptors of minus 8,3 kilocalorie per mole. This indicates that the camphoride and quercetin ligands with VEGF receptors form heterodimers to stimulate transcription of genes that regulate breast cancer cells proliferation. Here we show the interaction of the combination of camphoride and quercetin ligands with the VEGF receptor. The conclusion of our study. Number 1. Brawijaya ligands that have the potential to act as breast cancer anti-cancer include caffeic acid, colchicine, and camphoride. Number 2. Propolis ligands that have the potential to act as breast cancer anti-cancer include caffeic acid, mannitol ester or CAPE, tangeratin, and quercetin. Breast anti-cancer receptors that can be used as target for molecular docking simulation include estrogen alpha, estrogen beta, and VEGF or vascular endothelial growth factor. And number 4. Brawijaya and propolis have the potential to act as anti-cancer drugs through molecular docking simulation. And our team has registered copyright. That's all for our presentation. Thank you.